Dear students, I welcome you for the today's lecture in the subject of heat transfer, that is the difference between heat transfer and thermodynamics. Heat transfer is a different subject and thermodynamics is a different subject. The thermodynamics we usually study from the perspective of the physical chemistry. However, in our mechanical engineering also, we study the thermodynamics in much detail as well as the heat transfer. But our branch of chemical engineering that is associated with the heat transfer, it deals specifically with the equipments of heat transfer. That is your heat exchangers, evaporators, reboilers, furnaces. So all these heat transfer equipments, by keeping in mind for designing of these heat transfer equipments, we study our subject of heat transfer in the chemical engineering branch. So first we will try to understand what is heat transfer. Then we will see what is thermodynamics and its difference. So heat transfer, it's a science of how heat flows. The science of how heat flows. That means the heat is flowing and how that heat is flows. So science then deals with the method by which the thermal energy is able to move from one location to the another or from one object to the another. So it's a thermal energy that is getting transferred from one location. It is also talked in terms of location, or you can say from one object to the another object. So the temperature is the measure of molecular energy of an object. So the transfer of energy as the heat always flows from an object of higher temperature, that means the warmer object, to one of a lower temperature, that is the cooler object. This is also known as the thermal energy transfer. So you can call it the heat transfer as well as the thermal energy transfer. So we often are interested in the rate at which this heat transfer takes place. It is the rate at which the heat transfer takes place. So basically this subject is dealing with the rate at which the heat flows. The rate at which the heat flows or the movement occurs from the warmer object to the cooler object. At what rate this movement that is taking place is studied in the heat transfer. And as a result, when we talk the rate, so it is the function of time, that is the temperature as a function of time, that is dt upon dt. So this is of only concern, that is the dt upon dt is associated with the heat transfer. Heat transfer deals with the determination of the rates, that is dt upon dt, that is change in temperature with respect to time. Not only that, but the variation of temperature with respect to the distance also that is studied. That is what change in temperature with respect to the direction. It can be x direction, y direction, or z direction. So heat transfer stops when two mediums reach the same temperature. That is, the equilibrium has been attained. Then there will be no heat transfer that will take place. So heat transfer stops when the two medium reaches the same temperature. That means the equilibrium has been attained. That is, when we say equilibrium that has been attained, that means a steady state that is attained. That is dt upon dt. Change in temperature with respect to change in time, that will become equals to the 0. Here you can see the different operations where the heat transfer that is taking place. So in this figure you can see the different processes where the heat transfer that is actually observed. Now, how that heat transfer that takes place? There are three ways by which the heat transfer takes place. That is the conduction, convection, and radiation. In this figure, the wood blocks, they're burning. So, these wood blocks, you can feel the radiation heat. That means the electromagnetic waves that is getting transferred. Then because of the convection as well as because of the conduction, the metal rod that is getting heated is because of the conduction. So what basically requires in case of a conduction? Conduction needs a matter, molecular phenomena, and without bulk motion of the matter. So here when we talk related to conduction, that is the matter is required. You require a physical object, physical glass rod, physical metal rod, that is what is required. And there is a molecular phenomena, means inside this matter the molecules, they move, they vibrate, and as a result they transfer the heat energy. Then in case of a convection, heat carried away by the bulk motion of a fluid and needs the fluid matter. So in this, the convection, convective currents are developed, or the air that is getting heated. So medium is different. Medium is your air, or you can say the fluid that will be the medium. And in case of conduction, it is the solid metal rod that will be the medium. Here in convection, it is the air or the fluid that is there. So heat is carried away by the bulk motion of the fluid, means air that is getting heated, and as a result of heated air one feels the rising temperature. So needs fluid matter. Then third, that is the radiation, does not need any matter. Both conduction and convection needs matter. However, the radiation does not need any matter. So how the transmission takes place? That is because of the electromagnetic waves. That is because of the electromagnetic waves, the transmission of energy by electromagnetic waves. So looking at this figure, the conduction, when you consider the conduction, that is the metal wall through which one temperature is at a temperature T1, another that is at a temperature T2. So heat is flowing through from T1 to T2. That is why the T1 surrounding is at a red and T2 is around white. So heat is transferring from higher temperature to the lower temperature. So the solid medium that is required. Now the metal that is available, convection, but the temperature is moving fluid that is there. Heated surface is there for the metal over which the fluid that is moving. So fluid is getting heated from the surface temperature T1 to the surrounding temperature T2. Then third, that is the radiation, the electromagnetic waves, no medium that is required. Here also you can see all the three modes of heat transfer, that is conduction, convection and radiation. As well as in this pan also you can see the three modes of radiation. So the methods of heat transmission, that is the convection, conduction, radiation. There are two methods of heat exchange, that is the indirect transfer and direct transfer, and the flow of heat, that is either it's a steady state flow or the unsteady state flow. Now what are the units? Q, that is the amount of heat. Q is the amount of heat and is having the unit joules, J. Then heat transfer rate, that is Q dot. Watt, its unit is watt. It is nothing but the joules per second. That is the amount of heat transfer per unit time is the heat transfer rate. Heat transfer rate is the amount of heat transfer per unit time. That is Q upon T, which is equal to Q dot. Q dot is the having the units watts. Watts is nothing but the joules per second. Then the heat flux. Heat flux is nothing but heat transfer rate per meter square. Heat transfer rate per meter square. That is why it is having the units of watt per meter square divided by the cross-sectional area A, or divided by the surface area through which the heat is getting transferred. कौन से एरिया से हीट ट्रांसफर हो रही है, that is the area has to be taken into account. So heat transfer rate per unit area is nothing but the heat flux. And sometimes we are also using the heat transfer rate per unit length. That means in a particular length per meter, it is also taught. That is watts per meter. Heat transfer rate per unit length. That is watts per meter. So amount of the heat is in joules. Heat transfer rate is the joules per second, that is nothing but the watts. Heat flux, that is the heat transfer rate per meter square, and the heat transfer rate per unit length. In these three different terminologies, we express the heat that is being transferred. Here also you require the overall heat transfer coefficient, that is U, which is having the units of watt per meter square Kelvin. Then the individual heat transfer coefficient H, that is also the units of watt per meter square Kelvin. Then the individual resistance that is there, which is having the reciprocal of the heat transfer coefficient. So units become 1 upon H units. So that is meter square Kelvin per unit per watt. Then the heat flow, that is the amount of the heat flow, heat transfer into a system at a rate, that is nothing but watt, which is equal to joules per second. If you will see the different books or different terminologies, there's notations of Q, Q dot and small q dot, they may get varied. But you have to remember the units, that is the amount of heat, heat transfer rate, heat flux और the heat transfer rate per unit length. क्या units दिए हैं, उसके ऊपर से अपने को समझने का है what is there. Don't look at the notations, that is whether it's a Q or small q, Q dot, that may get confused from book to book, but the units will not change. Then the thermodynamics heat, the form of energy that can be transferred from one system to the another as a result of temperature difference. Thermodynamics is concerned with the amount of the heat transfer as a system undergoes the process from one equilibrium state to the another. It is the amount, quantity. And heat transfer rate, heat transfer, it deals with the determination of the rate. One is the amount and another is the rate. So thermodynamics is the study of the motion of the heat energy as it is transferred. This is what we talked related to the heat transfer. Now we will talk related to the thermodynamics. So thermodynamics, it is the study of motion of heat energy as it is transferred from the system to the surrounding or from surrounding to the system. किधर से किधर heat जा रही है, that is of not concern, but one is system and another is the surrounding. So thermodynamics is the study of motion of heat energy as it is transferred from surrounding to system or system to surrounding. The study of conversion between the thermal energy and other forms of energy. So thermodynamics deals with the systems in equilibrium. सिस्टम में इक्विलिब्रियम अटेन करने के बाद में thermodynamic calculations are taken into account. However, in case of heat transfer, it is the study and the change that is taken into account. Thermodynamics deals with the system in equilibrium. It is used to calculate the energy required to change from one equilibrium state to the another equilibrium state. So equilibrium states की energy we are considering for the calculation purpose, but it is not used to calculate the rate at which the change may occur. कितना टाइम लग रहा है, 1 घंटा लग रहा है, 2 घंटा लग रहा है, 1 दिन लग रहा है, 1 महीना लग रहा है, साल लग रहा है, that is not mattered in case of your thermodynamics. How much time is required to carry out this change is not concerned in the thermodynamics. So the transfer of heat could be due to the physical change or a chemical change. So in case of thermodynamics, we are having the 3 laws. That is the first law, which is related to the energy is conserved. The energy and matter can be neither created nor be destroyed, only transformed from one form to the another. That is, the energy and matter of the universe is constant. And these basic principles, they are also used in the heat transfer to develop the mathematical equations. Then the second law, in any spontaneous process, there is always an increase in entropy of the universe. The entropy is increasing. And the third law of thermodynamics, the entropy of a perfect crystal at 0 Kelvin is 0. There is no molecular motion at absolute 0. It gets freeze at absolute 0. So finally, coming to the specific points, the thermodynamics tells us how much heat that is transferred, change amount that is transferred, and how much work that is done. And it is more concerned related to the initial and the final states of the system. However, in case of the heat transfer, it is talk related to the at what rate the heat is getting transferred, how that heat is getting transferred, with what mode of heat operation, whether it is by conduction, convection or radiation, and depending on that, you are having the different calculations for the heat transfer rates. Then the temperature distribution inside the body. This is of more concern or more detailing of the heat transfer, the temperature distribution inside the body. That is when the variation with respect to time as well as the variation with respect to the distance. एक पॉइंट पे पर्टिकुलर इतने बजे इस पॉइंट पे इतना टेम्परेचर था, इतने बजे इस पॉइंट पे इतना टेम्परेचर है. So all this is the variation of change in temperature dt with respect to dx, that is the distance, or with respect to the time dt. However, this heat transfer and thermodynamics, they are complementary to each other. So there are a few systems which are there. For example, your thermos bottle. This bottle can be studied from thermodynamic aspects as well as your heat transfer aspects. When you study related to the heat transfer aspects, then we are considering at what time this hot coffee will remain as a hot. So how long it takes for the hot coffee in a thermos bottle to cool to a certain temperature, which cannot be determined from the thermodynamic analysis alone. Then in the subject of the heat transfer, we are having the two problems, that is rating problems and sizing problems. Rating problems which deals with the determination of the heat transfer rate for an existing system, that is the rating problem, and we are designing the size of the system in order to transfer the heat at a specific rate for the specified temperature difference, that is the sizing problem. We are designing a new, that means we are sizing for the specific conditions of temperature and pressure. In case of rating problem, it is the existing system has to be checked whether it will fulfill my conditions of temperature and pressure and the certain flow rate. And one can be there, the experimentally and analytical analysis has to be carried out. That is, the experimental approaches, they are time consuming, requires a lot of efforts, energy. However, the analytical approaches, the results are faster with the minimum amount of the energy. So analytical approach has the advantage that it is the fast and inexpensive, but the results obtained are subject to the accuracy of the assumptions, approximations, and idealizations made in the analysis. So this is the two approaches, experimental approach and analytical approach. The designing is related to the rating problems and the sizing problems. In case of the sizing problem, log mean temperature difference has to be taken into account. However, in rating problem, you take the number of transfer unit, that is NTU, as the basis for calculation purpose. Generally, when you do the analytical approaches, you have to design a certain model. So models are very much essential or important from the perspective of the analytical approach instead of having the experimental approach. So this modeling is the powerful engineering tool that provides the great insight and simplicity at the expense of some accuracy. Then the physical problems one has to study, that is identify certain important variables first, then analyze the system accordingly so that we can minimize to obtain the suitable equations, make reasonable assumptions and approximations which will minimize the number of variables, and a solvable differential equation can be obtained by the application of the relevant physical laws. So different basic laws, the conservation laws that will be required to develop the differential equation. And without these basic laws, that is the one-dimensional heat transfer equation or three-dimensional heat transfer equation in the Cartesian coordinate system, spherical coordination system, and cylindrical coordination system, we are going to discuss it. And then finally those equations are to be solved with the different solution techniques, and the boundary conditions are to be applied so that you will get the solution of that problem. Then we have to learn the heat transfer. There are many applications in the chemical as well as mechanical as well as in electronics nowadays, where you have to design uh, the heat exchanging equipment, either the fans or coolers, blowers, or the design of the heat exchanger, which makes the perfect operation and the desired temperature. Obtaining the desired temperature is the basic purpose of designing the heat exchanging equipment. Then the applications, the energy production and conversions, then steam power plants, solar energy conversions, then refrigeration and air conditioning, domestic applications like your ovens, stoves, toasters, then cooling of electronic equipment, then manufacturing and material processing. Manufacturing means all our production units, then the welding, casting, soldering, laser machining, then automobile as well as the aircraft designing. Then nature also, you have to study the heat transfer, weather and climate changes.